We can use our calculator. We can show this. If I take like 25 and I raise it to the 0 power, no, it's 1. Notice if I take a negative power and I raise that to the 0 power, it's also 1. Remember, if it's outside the exponents, that's like negative 1. So if I take negative 36 to the 0 power, without the parentheses, that's going to be negative 1 because the negative's outside the parentheses. Just notice, anything to the 0 power is 1. So if I take a look at example 1 here, I'm going to violate my rule and notice I'm not going to do what's inside first because I want you to notice here is everything's to the 0 power, isn't it? So this whole thing is 1 on example 1. Now example 2, I don't have parentheses, so a to the 4th divided by a squared, that's a squared. B to the 0 is 1, so it's a squared times 1, which is a squared. Now let's go back to our chart, and let's finish up the pattern. So 5 after 0, that would be negative 1, following my chart. What's I can't write that very well. Let's rewrite that so it looks like a negative 1. So what's 1 divided by 5? Well, that's 1/5. So a negative exponent does not mean negative. 5 to the negative 2 power. If I take 1/5 and I divide that by 5, that's 1/5 times 1/5, which is 1 over 25. You see the pattern here? That is, when I have a negative exponent, it's just reciprocal. 5 to the negative second is the reciprocal of 5 to the second. So 5 to the negative third, I'm going to look at 5 to the third, that's 125, that's 1 over 125. So we can write this in a couple different ways. We can say anything to a negative power, I'm going to take the reciprocal and make my exponent positive. You might have learned this in middle school about throwing it over the fence. That's a little magic for me, but that's essentially what we're doing. What happens if I have a fraction and I raise it to a negative power? Well, what I'm going to do is I'm going to take the reciprocal first and make it a positive power, and then I'll use my power over my exponent. So it'd be y to the a over x to the a. So a negative exponent means reciprocal. It does not, under any circumstance, be negative. And once again, we can show you this on our calculator. If I take, let's use a number I'm used to seeing, 2, and I raise that to a negative 1 power. That's the reciprocal of 2, which is 1/2. Notice if I take 1/2 and I raise that to the negative 1 power, I will get 2, the reciprocal of 1/2. If I take 2 to the negative 3 power, so if I think 2 to the third is 8, so this should be negative 1/8. And negative 1/8 is 0.125. I can do the reciprocal and show you 0.125 raised to the negative 3 power. Notice I get 5/12. Oh, hello, because I did 1/8. Okay. Why did I get 5/12 there? Because that's 1/8. Oh, yeah. 8 to the third is 512. That makes sense. Okay. Sorry about that. Wasn't thinking very logically there. Now let's apply that to a couple of our problems. So on example 3, Notice nothing's the same. The only thing is all my negatives I'm going to switch around. So a to the third is not negative. That stays. And then c squared goes in the numerator. B to the fourth goes in the denominator. And we're done. Woohoo! Yay! Isn't that cool? And then let's take a look at example 4. First, I'm going to simplify this. I'm going to make this a bit bigger here. 3 goes into 36 12 times, and it's negative. No matter what I do, I'm going to get 12 in the denominator, and I'll have 1. I'll put 1/12 for now. That'll go away in a second. Now, we're going to subtract our exponents. Negative 3 minus 3 is g to the negative 6. H squared over h to the first, well, that'll be h, won't it? 2 minus 1. I got j to the negative 4. We can have negative exponents while we work. You can't have negative exponents in the answer because I want a monomial. Monomials don't have negative exponents. Well, they don't have fractions, so that kind of goes away anyway. So what I'm going to do is I'm going to take my exponents that are negative, and I'm going to flip them. Everything else is going to stay the same. I don't need that 1 anymore because I've got a numerator of h, don't I? And then j to the fourth goes in the numerator. 12 stays in the denominator. It's still negative. And then g to the 6 goes in the denominator. Negative numbers are negative numbers. We don't flip negative numbers. Only negative exponents do we flip. Why didn't I flip the h? Because the h is positive. It's h to the first power. So that stays there. I guess you could write h to the first if you wanted to. It's kind of redundant. I don't think the computer will like that. So it's negative h j to the fourth over 12 g to the 6 is our answer. And that's all we got to do. Woohoo! Work on your assignment.